So I want you to picture the birthplace of an 804 horsepower, entirely custom-built electric hypercar.
Oh, man.
Right. And you are almost certainly picturing this like pristine clinical factory in Stuttgart, or maybe the historic workshops of Maranello.
Or Silicon Valley, some ultra-sleek, glass-walled campus.
Exactly. We have these deeply ingrained assumptions about where extreme automotive engineering comes from. But I can guarantee you are almost certainly not picturing Tripoli Square in Colombo, Sri Lanka.
No, probably not. And that geographical bias is incredibly common. I mean, we're conditioned to expect top-tier automotive innovation to flow exclusively from these, established, heavily funded hubs that have basically dominated the industry for a century.
Welcome to the Deep Dive. Today, our mission is to explore the engineering data, the technical specs, and this wildly ambitious corporate vision behind Vega Innovations. They are the creators of the Vega, which is Sri Lanka and South Asia's very first all-electric supercar. We're drawing all of this from their official technical specifications and a really deep trawl through their YouTube channel archives.
Which are, frankly, a goldmine.
A total goldmine of engineering data. Okay, let's unpack this. How exactly is a South Asian tech company crashing the global multi-million-dollar supercar party?
Well, they're managing it by completely refusing to play by the traditional rules. I mean, instead of just buying a chassis and, throwing some catalog electric motors at it, they are focusing excessively on foundational engineering from the molecular level up.
Right. Let's start with the physical car itself, because the raw numbers are just staggering.
Oh, yeah.
We are talking about a fully electric two-seater supercar. It's wrapped in a handmade carbon fiber body driven by a dual-motor all-wheel drive drivetrain.
Which is no small feat.
Not at all. And that drivetrain produces 804 horsepower, 760 newton meters of torque, and get this, it does the 0 to 100 kilometers per hour sprint in just 3.1 seconds.
Insane.
For you listening, to truly grasp what 3.1 seconds the highway speed feels like, think about one of those high-speed magnetic roller coasters.
Oh, that's a good comparison.
You know that visceral, stomach-dropping launch where the air gets violently pushed out of your lungs and your head is just pinned to the headrest? That is the exact G-force this car is putting down on actual pavement.
What's fascinating here is how these raw metrics function as an instant equalizer.
How do you mean?
Well, in the upper echelons of the automotive world, performance numbers are the ultimate currency. You can have a century of racing heritage, but the stopwatch absolutely does not care.
Right. 3.1 seconds is 3.1 seconds.
Exactly. By hitting 804 horsepower and that 3.1-second sprint, a completely unknown prototype forces legacy automotive giants to take notice. They bypass the need for a legacy by simply engineering a vehicle that demands respect on paper and on the track.
But the specs also show it maintains a 300-kilometer range, which is powered by a 55-kilowatt-hour NMC Generation 2 battery pack.
Yeah.
And I have to pause here because looking at the market right now, standard long-range electric vehicles usually carry 80, 90, or even 100 kilowatt-hour batteries.
Yeah, that's true.
So 55 seems incredibly tiny for an 804 horsepower hypercar. Are they just sacrificing driving range to shave off a few pounds of weight?
It's a deliberate, highly calculated trade-off. See, in an electric vehicle, the battery is the single heaviest component, period.
Right.
If you put a 100 kilowatt-hour battery in a car, sure, you gain range, but you are now lugging around an extra 1,000 pounds.
Which ruins everything else.
Exactly. It ruins your handling, your braking, and most importantly, your acceleration. So by using a 55 kilowatt-hour pack, they are prioritizing power density and keeping the car as light as possible to achieve that 3.1-second launch.
And the documentation specifies it's an NMC Generation 2 pack. What does that specific chemistry bring to the table?
Right, so NMC stands for nickel, manganese, and cobalt, and each element serves a very vital purpose.
Okay.
Nickel gives you high energy capacity, meaning more power. Manganese provides structural stability within the battery cell, which is, crucial for safety.
Essential, yeah.
And cobalt helps with the lifespan of the battery so it doesn't degrade quickly. When they specify Generation 2, it implies a refined ratio of these metals that maximizes thermal stability while allowing the battery to just dump massive amounts of energy into the motors instantly.
So they're pulling an astonishing amount of power out of a relatively compact electrical reservoir.
Yes.
But generating 804 horsepower from a small system creates a massive, undeniable enemy in physics, which is heat.
Oh,
If you don't manage that heat perfectly, you aren't building a supercar. You're building a carbon fiber bonfire.
Huh. Yeah, well, that is the defining hurdle of high-performance electric vehicles. I mean, anyone can link enough batteries together to make a car go fast for about 30 seconds.
Right.
The actual engineering marvel is doing it repeatedly without melting the internal components into slag.
Well, here's where it gets really interesting, because the documentation states that absolutely all automotive electronics are designed and manufactured in-house.
Which is wild.
It is. That includes the motor controllers and the complex lithium-ion battery packs. But frankly, I struggle to understand the business logic there.
Really? Why?
Because building a 900-volt system is highly volatile and incredibly dangerous. We're talking about motor controllers capable of 350 kilowatts of peak power, operating at up to 900 volts and 600 amps.
Yeah, that's a lot of juice.
Why would a startup take on the massive headache of designing these hyper-complex electronics from absolute scratch? Why not just buy a proven off-the-shelf system from a major supplier in Germany or Japan, put it in your pretty carbon fiber shell, and go to market?
Well, if we connect this to the bigger picture, it all comes down to intellectual property and the absolute mastery of thermodynamics. Let's break down those numbers you just mentioned, 900 volts and 600 amps.
Okay.
To put that in perspective, a heavy-duty household appliance, like an oven, runs on 240 volts and maybe 30 amps.
Wow, okay.
Yeah. Pushing 600 amps through an electrical system is like trying to force a municipal fire hose's worth of water through a standard garden hose.
That sounds catastrophic.
It is. The sheer electrical friction creates catastrophic levels of heat. If they bought off-the-shelf parts, they would be constrained by the cooling limits of someone else's technology. By building it themselves, they developed proprietary liquid-cooled motor controllers using what they call a pin-fin structure baseplate.
Okay, let's define that, because pin-fin structure baseplate sounds like obscure aerospace jargon.
It does, yeah.
How does that actually solve the fire hose problem?
Think about a traditional flat metal cooling plate. If you run liquid coolant over a flat surface, the liquid only touches that one smooth plane.
Right.
That is a massive thermal bottleneck. A pin-fin structure is entirely different. Imagine that flat metal plate is suddenly covered in thousands of tiny, microscopic metal spikes.
Almost like the bristles on a metallic airbrush.
Precisely, like a hairbrush.
So as the liquid coolant flows through those bristles, it's grabbing heat from the front, back, and sides of every single pin.
Exactly. It exponentially multiplies the surface area for heat exchange without increasing the overall size of the component. According to Vega's specs, this proprietary technology massively reduces their manufacturing costs. But more importantly, it significantly enhances the lifetime of the solid-state devices inside the controller.
Because heat is what kills electronics.
Exactly. By aggressively wicking that heat away, the controller can survive the violent stress of an 804 horsepower launch over and over again.
And they apply a very similar aggressive philosophy to their battery tech, too. The specs note they're designing high-performance, liquid-cooled battery packs using both pouch and cylindrical cells.
Yep.
And the standout features here are dual-tab cooling and cell-fused battery assemblies. Now, dual-tab cooling sounds like another physical flow multiplier.
It is. So in a standard battery cell, the energy enters and exits through a single metal tab. Imagine a plastic water bottle.
Yeah.
The tab is the narrow neck at the top. If you squeeze that bottle to get the water out quickly, you get a ton of pressure and friction right at that bottleneck. In a battery, that friction translates directly into heat.
So a dual-tab design is like cutting the bottom off the water bottle as well. The energy can flow out of both ends simultaneously.
That is exactly the physics at play. By utilizing two tabs, they effectively cut the internal electrical resistance in half. Less resistance means less heat generated in the first place, and it provides two separate pathways to draw whatever heat is created away from the cell core.
That's brilliant.
Combine that with their cell-fused assemblies, which basically means if one individual cell catastrophically fails, a microfuse blows and instantly isolates it so the entire pack doesn't catch fire, and you have an incredibly robust, world-class battery management system.
So mastering this thermal dynamic, the pin-fin structures, the dual-tab cooling, that's really the core magic of EV performance. And because they built it entirely from scratch, they own the patents.
Yes.
Which sort of shifts my entire understanding of what this company is actually doing.
Oh, absolutely. The supercar itself is almost a distraction from their true product.
A distraction.
Well, the car is simply the Halo project. It is the ultimate, highly visible stress test for their underlying intellectual property.
So what does this all mean? To me, it means Vega isn't just a boutique car manufacturer making toys for billionaires.
No, not at all.
They are positioning themselves as an arms dealer for the global EV revolution. They are building and supplying the underlying nervous system, the brains and the brawn for the future of transportation.
That arms dealer analogy is incredibly accurate because their technology is inherently modular. I mean, a custom motor controller capable of handling 900 volts and 600 amps for a hypercar is a marvel. But Vega explicitly states that their expertise allows them to scale this exact same technology all the way down to electric two-wheelers.
And the two-wheeler market in Asia and globally is astronomically larger than the hypercar market.
Oh, without a doubt.
If you are a startup wanting to build electric delivery scooters or city commuter bikes, you don't need to spend 10 years and billions of dollars inventing a thermal management system. You just go to Vega.
And they are actively welcoming that exact scenario. They're offering their research, development, and testing capabilities for high-performance battery pack designs to customers worldwide. They are taking this hyper-efficient, liquid-cooled architecture and turning it into a plug-and-play platform for other manufacturers.
You can actually see this specific business strategy validating itself in real time on their YouTube channel.
Yeah, the views are crazy.
They are. The hype from their audience isn't just around the supercar doing burnouts. They have a video titled Vega EVX Platform that has a massive 726,000 views.
Think about that.
That is a staggering number for a highly technical B2B video showing off a bare chassis and battery architecture.
Right.
And there's another highly viewed video called Introducing Electrotech, which showcases this broader hardware scope. Hundreds of thousands of people, likely automotive engineers, procurement officers, and investors are watching simply to study the underlying architecture.
Consider the massive disruption this represents. Right now, the global electric vehicle supply chain is heavily monopolized by massive Western conglomerates and giant Chinese tech firms. If a modular, highly efficient, and scalable electric platform originating from South Asia can provide comparable or superior thermal management and power density, it threatens to completely upend that monopoly. It provides an independent, alternative source for the core technology the entire world needs to transition away from fossil fuels.
Which naturally brings us to the most unique part of this entire story, which is the location itself, the heart of the mission. This 900-volt, 804-horsepower engineering marvel is being built at Trace Expert City, specifically in Tripoli Square, Colombo, Sri Lanka.
Yeah, and what makes Trace Expert City so vital to this story is that it isn't just a factory, it is an incubator. Vega Innovations is deeply intertwined with a network of other local tech entities sharing the exact same physical space. You look at their corporate network, and you see companies like Agro, which focuses on AI and tech, alongside ChargeNet, which builds electric vehicle charging infrastructure, and their own dedicated design studio.
So they aren't working in a vacuum. It functions like a localized, hyperdense Silicon Valley.
Precisely.
You have software engineers from the AI side bumping shoulders with the infrastructure experts from ChargeNet. The people building the charging stations are talking daily with the people building the battery packs. They understand the grid limitations, the software requirements, and the hardware realities all under one roof.
It creates this incredibly rapid feedback loop of innovation, and it's all fueled by a very specific, almost audacious guiding philosophy.
Yes, they have this core mandate to dream big. If you dig back into their YouTube archives, there's an 8-year-old video from back when they were just starting this seemingly impossible journey.
I love that video.
Right. Their visionary leader, Harsha Subbosa, looks right at the camera and says, when you dream big with passion and commitment, dreams do come true. Anything is possible.
And, you know, in a vacuum, a quote like that sounds like standard, hollow corporate motivation.
Should be cliche, yeah.
Right. But when you place that quote next to a 3.1-second supercar sitting on the pavement today, you realize it wasn't just motivational speaking. It was a literal roadmap.
But I do have to poke a little fun at some of their broader marketing language here.
Oh.
In their vision statement, they describe themselves as a hyper-creative generation of multidisciplinary innovators wanting to enhance lives. And here's the direct quote, bring people closer to nature and to each other in extraordinary ways.
Okay, I see where you're going with this.
I just have to ask, how exactly does a tire-shredding 804-horsepower electric beast bring a driver closer to nature? It seems a bit contradictory.
This raises an important question, and it actually points to a really beautiful paradigm shift in modern engineering.
How so?
Well, for the last 100 years, automotive passion and environmental responsibility were fundamentally at odds. If you wanted visceral, gut-wrenching performance, you had to burn massive amounts of fossil fuels and actively pollute the environment. The contradiction you're pointing out used to be an unavoidable law of physics.
Right. If you wanted to go fast, you had to be the enemy of nature.
Precisely. What Vega is doing by flexing this immense engineering muscle is proving that zero emissions technology, which is the closer to nature part of the quote, does not require you to compromise on world-class performance. They are using pure mathematics and advanced thermodynamics to eliminate the guilt of performance.
And they actually lean into that specific messaging. They have a video on their channel called Uncompromised Performance for a Greener Tomorrow, and another simply titled Vega on the Roads of Colombo, which has over 133,000 views.
Yeah, that video is stunning.
It is. When you watch it, seeing this low-slung, futuristic hypercar silently navigating the real-world, everyday streets of Sri Lanka, it visually proves that the dream is a reality. It fundamentally shatters geographical stereotypes about where top-tier innovation is allowed to originate. They're proving that a sustainable future doesn't have to be a compromise. It can be incredibly thrilling.
It forces the global industry to recognize that genius and capability are evenly distributed around the world, even if traditional funding and infrastructure are not. I mean, when a small team in Colombo masters dual-tab cooling and pin-fin architecture before some legacy automakers do, the map of global innovation is permanently redrawn.
It's an incredibly powerful realization. And for you listening, you might be thinking, this is a fascinating story, but I'm probably never going to sit in, let alone drive, a handmade carbon fiber electric supercar.
Sure.
But the reason this matters, the reason you should deeply care about what is happening right now in Tripoli Square is because of that platform potential we broke down earlier.
Absolutely. The technological trickle-down effect is going to be impossible to ignore.
Right. As the global transition to electric vehicles accelerates over the next decade, every single automaker on the planet is going to need lighter, cooler, more efficient electronics. The proprietary dual-tab cooling battery architecture, or that specific pin-fin structure motor controller inside your next daily commuter car, or even the battery management system inside your next electric city bike. It might very well be powered by the technology developed, patented, and stress-tested by this exact team in Sri Lanka.
They have irrefutably proven they have the intellectual property and the raw engineering talent to run with the heavyweights. They solved the heat problem, they solved the weight problem, and they solved the power density problem. Now, it's strictly a matter of scale.
Which leaves us with a final provocative thought to mull over today as you go about your week.
Let's hear it.
If a multidisciplinary team in Sri Lanka can successfully build an 800-horsepower, 900-volt EV platform completely from scratch, entirely using their own proprietary intellectual property, what does that mean for the traditional gatekeepers of automotive engineering? Does the future of extreme automotive performance really belong to the century-old legacy brands we've always known? Or is the next century of transportation going to be dominated by agile, hyper-creative tech startups emerging from markets the old guard never saw coming?
It's a reality that should force every legacy boardroom in Stuttgart, Detroit, and Tokyo to severely reevaluate their competitive landscape.
It certainly changes the mental image, doesn't it? The next time you try to picture the birthplace of the ultimate driving machine, maybe you shouldn't be picturing the traditional hubs at all. Maybe, just maybe, you should be looking toward Colombo.